Hi, today I'm going to give a brief overview and demo of the Oden platform. Oden is a manufacturing analytics platform, which is really an insights layer that sits across production systems, such as your machine data, your ERP, MES, or quality data, pulls all that data together into one single source of truth, and then contextualizes and visualize that data in a way that allows plant teams to identify the biggest areas of inefficiency to improve things like throughput rate, reduce downtime, and improve overall yields. So we're in the platform, which is a cloud-based platform. You access it through a web browser, and I'm going to be showing you live customer data, but it's been scrubbed to not show anything proprietary. We're starting in the now view right here, which is just that, intended to look at the plant floor in real time and show a line-by-line breakdown of the state history of the line, different KPIs, related to OE or other things that are important to your organization, as well as maybe process metrics like how fast you're running and context information coming in from ERP or MES, such as the product and batch. This now view is completely configurable. So the KPIs that we have listed here, the columns, the breakdown of this, the color threshold is all configurable to the user and can be done, at the individual user level, meaning how an operator may want to see this versus a quality technician may be different, and they can each create their own unique view. In addition to this line level breakdown, you can also see this in more of a Jumbotron version. So this gives, a very quick indication, red or green, whether the line is up or down, and some key KPIs. This is something that you could probably put out on a TV screen to see this more easily. You can then dive into any given line and actually start to see real-time process metrics. We're showing the tile view, which allows different users to monitor that in real time. You can establish upper and lower limits, as you can see on both machine speed here and actually predictive quality. So this is an example of our advanced analytics where we're taking the real-time machine or process data combined with the context data from ERP, as well as the offline quality data, and actually predicting quality in real time and then streaming that with upper and lower limits. You can see there's a variety of other metrics that are being streamed here, and this is completely configurable. I could add in another metric or remove that. I can also see this in a chart view where you're overlaying the metrics instead of a tile view. Next, I'm going to dive into our dashboard view, which is meant to build out a variety of different dashboards and reports so you can see trends over time and look at key KPIs. This is a customizable interface. You can make as many dashboards as you want. Our customer success team will help deploy several dashboards and also train your teams on how to use this tool. As you can see, to configure dashboards, it's an easy drag and drop interface where I can create different modules or dashboards based on different users. In addition, we have the ability to do what's called OQL, Oden Query Language, similar to SQL query language, but really designed for manufacturing and the type of intercepts that manufacturers like to see, where you're intercepting time series-based data with context data, such as the type of product, the shift, or the line that it's running on. To give you a couple examples of this, we're first showing OE trends over time, broken down, monthly, also showing that on a line-by-line breakdown, looking at availability and performance as well as quality. You may want to take this a level deeper and start to understand really what's driving those OE results. So here's an example of an availability dashboard where we're starting to show the categorization rate of how well your operators or supervisors are categorizing downtime, broken out by line, the top causes of downtime based on that categorization, as well as the downtime hours over time, and then really start to get into some unique analytics here where we're looking at the frequency of events as well as the average duration by events and how that compares by shift. I'll take that even a step further in the supervisor's view, where we're really trying to hone in and help do some of the advanced analytics or data analysis in advance, and therefore present a dashboard that already starts to highlight some insights. many manufacturers have too many problems to deal with. So a very unique aspect of Oden is being able to highlight or spotlight the biggest areas of opportunity or biggest areas of issues. To give a couple examples here, we're first showing performance loss looking at the previous day. And it shows that, this client almost lost 2 hours of performance due to the top 5 product line combinations, whereas they didn't lose any performance on the next 12 product line combinations. Again, helping prioritize that. Same on the bottom graphic here, but now we're looking at the previous week. Again, you lost 12.3 hours compared with the top 5 product line combinations compared to less than 3 hours on the next 35. This makes it very easy for a supervisor to prioritize what are the biggest areas of performance loss and quickly see how much output was lost, what is your average speed compared to target, and what is our performance baseline. We do the same thing for quality, where we're showing variation in scrap, as well as downtime, understanding what are the biggest downtime events that are contributing to that. What's great about this is not only does this dashboard quickly help prioritize, it also allows them to drill into one of these given scenarios and start to understand the process data behind this instance. And so I'm just going to look at a quick example here. Because we were looking at performance, I'm going to pull up machine speed here. And I'm actually going to ask the system, show me what baseline behavior is for this product. And what the system's going to do here is actually overlay what is the baseline behavior. And as you can see here, the darkest orange line here is where they're consistently running. They also run a little bit lower here and even a little bit lower here. So you can see, on a pretty consistent basis, they're hitting that 220 speed throughput here. But during this time period, they're running just over 200. They also often run at that 150 mark. So this could be, different operators or different situations where they're comfortable running at different speeds. So it makes it pretty easy to, break that down and help somebody start to investigate that. I want to dive into another quick example of dashboards and how you can drill through that. So here's an example of Discover, which allows you to really do a Pareto analysis by line, by product, by shift. I'm starting with utilization here, and I can start to break down what are the top causes of unplanned downtime and actually drill into this. And I can start to see, for example, the night shift, first and foremost, has the most unplanned downtime. A lot of this due to machine jam and wire breaks. Maybe that's a training issue. I can see a specific product here is having a lot of wire breaks. Another one that's running into a lot of machine jams. And lastly, on certain lines where I'm seeing the differences here. Now, wire break is something that's pretty consistent across all 3. So maybe I want to filter into that in particular. And what I can do here now is actually ask the system to open this up and explore. What this then does is basically set up an automated query that went and pulled all of the downtime events for a certain time frame that were caused by wire breaks. I can then sort by duration to look at the ones that cause the heaviest downtime, and then I can drill into that specific instance in time. As you can see here, this was that downtime event that was roughly 11 hours. And I can start to inspect the time period leading up to this downtime event. And maybe I want to, ask the system, hey, what was happening most abnormally during this time period? Maybe I'm a process engineer and I know that. Maybe I'm a supervisor and operator and I don't. But this can really help, somebody understand in their root cause analysis, is there anything happening abnormally leading up to this downtime event? What the system's gone here and done is reordered these metrics here based on a separation score, which is the score you're seeing under each metric. You can see tank pressure 1 has the most variance that we're seeing. So meaning it's the most difference from the baseline behavior. And now that I overlay what that looks like, you can see there's kind of 2 main operating norms for this tank pressure. Up here at that 4.2, and then down here, it looks like just under 4. You can see a dip here But that was, several hours prior to that downtime event. So I can't say for certain that, this is what caused that downtime to occur, but you can start to see how the system is starting to guide the user on, what's causing those downtime events. To take that a step further, this Explore tool is very powerful. So think of this as, the ability to query, whatever type of data that you're looking for. So just to give another example here, I could ask the system to show me the top scrap by product. Maybe I'm more interested in looking at yields and scrap. And you can see now, by product, I can see where I had the highest levels of scrap. There's a lot of flexibility to group this by, different products, lines, shifts. I can filter things out, and I can also add in different measures, whether that's a KPI or a specific metric. So this becomes a very powerful tool. You can share these views. I can export these views. I can save these queries. So very powerful query tool. I'm going to wrap up here showing just two quick examples of some of our advanced analytics. So I'm first going to go to our an example of where we're predicting quality for a customer. I think I showed a now example of that earlier on where we're streaming that in real time. But this allows us to actually take those offline quality measurements, incorporate the real-time process data, and actually make a predictive model that is predicting that offline quality in real time. What's great about this is we actually expose the model coefficients and then show, how those process metrics correlate to the actual predictive quality metric so that the customer can start to understand the process measures there. Just to remind you, back in the tile view here, we actually then predict that quality in real time so somebody can see that with upper and lower limits. And then I'll show one other last example here where we're actually using that to do what we call predictive process optimization. And this is where the Oden system is going out and looking at your historical behavior and automatically prescribing how can you maximize output while also minimizing costs, but also taking into account that predictive quality. So you can see here, we saw a cost variation of 8 to 20% potential reduction. And we're actually prescribing the process settings needed to reduce that cost at different throughput rates. That really wraps up the demo for today. I hope it was valuable to you. If you saw something today that you'd like to learn more about, please reach out to the Oden team, and we're happy to set up a further demo unique to your application. Thank you.